Campbell scientific data loggers store measurements as numbers, called float values, not as text. If I want to show those values in a message, save them in a text file, display them on a screen, or send them to another device, I first need to convert them into text. In this video, I'll show how to do that using a simple test program in the CRBasic FormatFloat instruction. In CRBasic, there are two instructions that can be used to convert float values to text: FormatFloat and sprintf. FormatFloat is most useful when I have one float value and I want to format it as a string with a controlled width and number of decimals. FormatFloat is great for building pieces of a larger message. sprintf is best for building formatted strings from one or more values. I'll cover sprintf in the next video in this series. In CRBasic, FormatFloat is used to convert a floating point number into a string variable. The FormatFloat instruction has two parameters, and the converted text is stored in a string variable. String is the string variable where the result of the format conversion will be stored. Float is the number to be converted to a string. Format string specifies the width and precision of the formatted value. The string and the float parameters are easy to understand, but at first glance, the format string parameter is tricky. Let's take a closer look at format string. To those familiar with C programming and the printf command, these codes will probably look familiar. If not, don't worry. I'll explain the format specifiers now. The format string parameter always begins with the %sign. The %sign is required and indicates that the characters after it specify formatting. If a specific field width is needed, it is placed next in the format string. In this example, the width is 8, so the formatted value will contain a total of 8 characters. If a specific width is not needed, this can be omitted. Width is most commonly used for column alignment. If a specific precision or number of decimal places is needed, that is indicated with a period followed by the number of desired decimal places. This is also optional and can be skipped if not needed. The final element of format string is the type code. Here are the possible type codes. F is fixed decimal. Lowercase or uppercase e is scientific notation. Lower or uppercase g is a smart code that automatically chooses the most compact format to display. This table from the CRBasic help shows how the various options for the format string parameter affect the formatted value outputted as text. Now I will demonstrate a simple CRBasic program that can be used to test how format string works. I will start with the example program in CRBasic and modify it so I can easily test the format string parameter. I'll begin by initializing the float to 22.5 for testing. I'm adding the form test string variable to make it easier to change the format string type code for this demonstration. Now I can make sure my modified program compiles and then send it to my datalogger. I'll use the Connect screen in LoggerNet to see how changing the format string changes how the value is formatted. I will begin with the default format string %f, which does not specify width or precision. With this format string, the string value has 6 decimal places. This is true regardless of what I change the float value to. Next, I will change the format string to include width. I will set the width to 5. Important notes: the width is a minimum field width, not a maximum. Width only affects column alignment or padding when the string value is shorter than the specified width. If precision is not specified, it defaults to 6 decimal places. So a value like 22.5 would be formatted with 6 decimal places, not as a 5-character string. Now I will test adding precision to the format string. I will set precision to 3, so I should see 3 decimal places. Next, I will change the type code to E so I can see how the string looks in scientific notation. I will change F to E in the format string. Now the string value is in scientific notation. The last type code available is G for a general number. This is a smart code, meaning that it will always use the shortest representation of a number. I will change the type code from E to G. Now my string is as short as possible. Notice that since width is specified as 5, but there are only 4 characters in my string value, a leading space was added. By default, if the specified width is greater than the number of characters returned, leading spaces are added. If I want to change the spaces to zeros, I can add a 0 before the width. Now the string is padded with a leading 0 instead of a space. Using this type of padding is a good way to keep columns in a text file aligned. If I want to add literal text to my converted string for something like an alarm message, that is easy to do. I simply add the text in the format string. Any ASCII character can be included in the format string. For example, FormatFloat variable, the current reading is %5.3g. Just be sure that the entire string is enclosed in quotes and that the string size is declared large enough to hold all the characters. In this case, I will change the output string size from 10 to 50. This string can now be sent to another device using serial out, or saved to a custom log file on the datalogger. Sensors produce numeric float values, but downstream systems often require specific string representations, such as fixed decimals, for example, 23.46. Specific separators, comma, tab, pipe. No scientific notation, for example, 0.000123 instead of 1.23 times 10 to the negative fourth. Consistent field order and line structure. FormatFloat is a great tool for converting a single floating point value into a string. In the next video, I will demonstrate using sprintf to combine multiple values and text into one call, or have each field formatted with its own precision in a single format string, for example, %.2f, %.1f, etc.